All right, welcome back, everybody. This is the last week of class. So congrats, you made it. Maybe it wasn't long enough. Maybe it was too long. I don't know. But I just want to say I really appreciate everyone's hard work throughout this week, through the past 7 weeks, 8 weeks, I guess. This is definitely like the class that has changed the most since I started. Usually there's like small little releases every week, every time that I teach a class. This time there happen to be like 3 or 4 big releases whenever I taught class. So actually there's a new one this week, which is Stable Diffusion released Stable Diffusion 2.1. So we have that fun excitement to look forward to. We'll actually look at one of the new Stable Diffusion models a little bit. So Adam requested that we take a look at this model, so we'll look at it today. The other thing we're gonna look at today is how to actually set these up on a server you can rent. So obviously there's stuff like AWS, GCP. We're gonna look at some cheaper options in those. So look at how to do that today. And as a part of that, we will look at how to run the depth to image model, which is kind of a cool new model that Stable Diffusion released with Stable Diffusion 2. So yeah, I think the 2.1 release, as I understand it, based on what I've seen so far on the internet, is it's moving slightly back toward how Stable Diffusion 1 worked in terms of how text prompts work and things. So I think they got enough feedback or a lot of pushback from people on 2 being too different. So now they're kind of like changing it a little bit more and going back to where their previous text prompts were. Probably not one or the other. It's probably like somewhere in the middle. So you kind of have to still play with text prompting to try to figure out how it all works. So just be aware of that. We probably won't look at that exact model today. Well, we might look at one of them. We might look at like the 768 model. So we can go ahead and start with that. So what I plan to do is just I'll go through that material. It might take an hour plus, a little bit over an hour, based on my previous class, and then we'll sort of save time at the end of class for any last minute questions. If anyone wants to share anything they've been working on, please feel free to do it either here in class or on the Slack channel. And then we'll take it from there. Is anything significantly better with 2.0? I don't think anyone's better. I think, as I mentioned, maybe last week or the week before, I have a suspicion the main reason they released 2.0 was to get around legal issues. I think there was a big issue around, there was quite a lot of porn in the previous data set that they were training on. So I think there's a lot of concern around that. There was certainly concern around copyright issues. So I think what they did is, in consultation with some lawyers, made some changes to the data sets they were training on to sort of get themselves a little bit away from there. And then also the big change was just that they moved off of clip into open clip. Again, I think that was kind of partly a legal thing to do that. So I think 2.1 is really just them kind of like retraining the models a little bit more to get closer to sort of how the prompting worked in the previous SD 1.4 or 1.5. But yeah, I wouldn't say anything was significantly better. I will say with the new models, they did release a 768 by 768 model, which I'd say that's better. It's another 256 pixels or whatever. So in some ways that's better. And they did release this depth to image model, which I'm really interested in. We'll look at it today. I played around with a little bit on it, and it's not as great as I would have expected, but it's actually pretty interesting or pretty helpful in certain aspects. So we'll take a look at that. So there were some new additions with 2.0 that I think are improvements, but I wouldn't say they're necessarily significantly better. All right, cool. So let's get started. So obviously one of the big challenges I think we all have with this is, let's say you want to run a cool little week-long exhibit, like as a part of an art installation, or you want to set up your own website where you create your own custom model and people can play with. Asking people to use a Colab notebook is kind of hard. We've spent 6 weeks using our own Colab notebooks, and it's still kind of hard, right? That particular web GUI is not the easiest to use. It's really powerful, but it takes a lot of learning to sort of understand it. So what are the options do we have in order to like set something up like this, right? Colab has a limit of 18, 24 hours. Let's say you want to run something for a whole week, just to have people access it. You could, of course, go to something like GCP, which is Google Cloud Provider, and they have their own set of GPUs you could rent. So we could go there and let's see what their pricing is. So Google Cloud GPU pricing. And if you scroll down here, you will see here are the prices for their GPUs. So for us, let's see if they even offer a T4. Yeah, so a T4 which is basically what we get with Colab Pro. The pricing is, I'm not exactly sure how they compare spot pricing versus GPU pricing. What is spot pricing here? Spot prices are dynamic and can change once up to every 30 days. They always provide discounts. Okay, so at the cheapest, we're talking 31 cents per hour, and that's per GPU. So that is based on sort of what we already use. So let's see if it's, it was 0.31 times 24 times 7. So if you were to try to run this for a whole week, it would cost $52 is sort of what we're looking at here. So that's the price of Colab Pro or Colab Pro Plus, right, for a whole month. And you could probably actually run a T4 for most of a whole month, maybe not back to back sequentially, but you could run it for a pretty long period of time. Colab Pro Plus with the higher GPU gives you an A100, and that is 88 cents per GPU hour. And again, I don't really know the difference between these. Usually you end up paying this price, so I don't know what this price exactly gives you. But let's try this. So 0.88 times 7 times 24, $145 for a week use. So these are getting kind of expensive, right? GCP also doesn't really provide any out-of-the-box usage of these things. So you have to go in and install them all. If you know how to set up a stable diffusion model, you know it's a lot of installation, installing the right version of PyTorch, all these other things. So not only is this like fairly expensive, but it's also a lot of work. So we're gonna look at two different options this week. They're a little bit cheaper. I will say for stable diffusion, the only one you should really be using is RunPod. I'll talk about that in just a minute. The other one would be Vast.ai. I don't know if we've talked about Vast.ai in a previous class, but both of these, the way they work is this idea of they have a market or a community market of GPUs. So kind of like Airbnb, where someone rents out their house for a week that they're away. This is sort of the same idea with these GPUs. You're renting someone else's GPU and you're renting it from them for a set period of time. And the idea is they're probably, waiting, they're probably between a project themselves. So they're renting out a GPU in the hopes that in the week they can sort of make some money back on it. And then they in turn will like stop and use their own model and stop it and use it for themselves. So for Vast, this one's actually also quite like complicated to figure out what GPU you should get. Excuse me. If you want to, you can sign up for Vast.ai. And I believe once you create an account, they give you like a $2 credit just to sort of play around and use a GPU. So how do you figure out what is the right GPU to rent here? One of the big challenges with Vast is there's so many different configurations. There's so many different GPUs. And there's this thing called DLPerf, which is like a score they've kind of made up to determine like what they think is the most performant GPU. So I think the idea would be you want the best GPU for the lowest price, but that can get pretty complicated. The other thing I would say is so stuff where like, if you're going to train your own model, like we looked at 2 weeks ago in training, that requires at least a 40 gigabyte GPU. So if you know you want to do training, then you know you need something larger than what is usually on offer, which is something like 24 gigabytes. So you could, I look at GPU RAM, you could crank this up to, let's say 40. And you can see what your options are, right? So one of these, now it's important to know this is not for a single GPU in this case, right? $2.60 is quite expensive, but that is for 6 A6000 GPUs. So this would probably train one of our diffusion models in a couple hours. So again, you also have to balance out price per hour versus how long you want to train for, all that sort of stuff. An A40 would be 45 gigabytes. So this would be, $1.20 per hour, and it's also 2x. So if you want to do training, there's still some good options here. These prices look expensive, but I would say in general, these are probably pretty fast. You'll train a model very quickly using these tools. Let's say you just want to do inference. Just using the web GUI could use, I think you need at least a minimum of like maybe 16 gigabytes. You could probably go a little bit lower, but I think shooting for 16 is pretty good because that's what most GPUs are available at that price. And here again, you'll see, some fairly decent pricing. An A5000 at 52 cents per hour for 2 of them. So let's divide that in half. That's 26 cents per hour. This is comparable to an A100 that they were offering on GCP. So that's about a quarter of the price, right? So a lot faster, or like a lot cheaper for about the same price. Plus, it's probably gonna be about a little bit faster because it's using 2 GPUs. Now, you don't really need 2 GPUs for inference because that's kind of overkill. You can't actually train on, or you can't actually generate images on 2. So if you're just doing inference, you kind of want just the 1x. And this one's kind of expensive, probably because it's a brand new GPU. You could probably go down here and just look for something that's 1x and cheaper. So 1x A4000, 21 cents per hour. So again, about a quarter of the price of what an A100 was on GCP. To rent one of these, again, the challenge with Vast is that you do need to kind of know what you're doing, and you kind of do need to know what you're building. So over here, you can go edit image and config, and you can select PyTorch, which is what all of Diffusion runs on. And if you're going to use a new StyleGAN model, it's also what most of the new StyleGAN models run on. You could also, if you know what Docker images are, or if you have a Docker image for particular models, you could put in a custom Docker name or a Docker image, and it would also support that. Again, this is kind of getting further and further away from what we think is feasible for what I assume most people taking this class are. Some of you might be developers and actually know how to use these tools. I'm going to assume you don't, which means this is getting further and further away from like regular capabilities that you and I could use. When I have used Vast in the past, I've had to build pretty complicated bash scripts in order to set up and install everything. So there is no default Stable Diffusion model you can run off these. At least I don't think so. I'd have to look to see if there's a Docker image for Stable Diffusion. But regardless, this is going to require a lot of setup. So go ahead and hit select on one of these, and then you can select all these other things. The other thing you'll want to do is you'll probably want to run a Jupyter notebook. We'll look at that in 1 second. That's probably the easiest way to run these. And Jupyter notebooks are very close to Colab notebooks. The difference being that Colab notebooks have some fun, nice features that integrate with other Google experiences like Google Drive. This does not. So Jupyter will not have the exact same features that a Google Drive or a Colab notebook does. I'll go ahead and just select this, and then we'll just rent one of these. So I'm going to rent one of the cheapest ones I can find. I'm only going to run it for maybe 20 minutes, so it probably won't be that expensive, but I'll run it anyway. So I'm just going to rent this. I hit the wrong button there, but that's all right, whatever. And then once it's rented, you go to instances. And over here, you'll see that your instances are running, and then it starts to load. So it's basically installing all of the code you need in order to run off this GPU. And as it says, it takes about 30 seconds to run. And at somewhere here, it's going to say ready or run. And when you hit that button, you'll then open a Jupyter Colab notebook. Well, I just called it Jupyter Colab, a Jupyter notebook, which is similar to a Colab notebook. What I'm going to do is, while I wait on this, I'm actually going to open up our Colab notebook that we usually use. And so you might think like, cool, let me just copy and paste all these cells from here into the Jupyter notebook, which in many cases would work fine, except our very first cell here is using Google Drive to connect to our Colab notebook. This will not work for Jupyter because the Colab setup does not connect. So already we can't really use this notebook in the same way we might use a Jupyter notebook. And in fact, I tried this earlier today. I tried to see if I could run this cell of code. And in fact, a bunch of the paths here are hard coded to where Drive is. And that causes a bunch of issues. The last thing I'll say, I'll just sort of spoiler this for you, is that Vast runs off of a root user, and Stable Diffusion kind of forces you to not use a root user. So to actually get Stable Diffusion running on a Vast.ai setup is really complicated. You have to sort of like provision new users and like go in and do all that sort of stuff. So spoiler alert, the challenge is that like Vast.ai doesn't really work for Stable Diffusion. It does, if you use StyleGAN, it does actually work pretty well for StyleGAN. So if you want to train models in StyleGAN, like, the way Colab Pro Plus is set up, it doesn't really allow you to really train big models in it these days in StyleGAN. You could actually use Vast to do that. When you open up Vast, you'll get this page, which is just a Jupyter page. You go ahead and say new Python 3. And then this, these are just cells, just like any other cell you would see in Colab. So you could, assuming that we have the right code here, we could actually copy and paste these cells over, and they should work, except in this particular case, we have all these hard-coded paths. So what you could do is you could actually go to the automatic 1111 repo. So maybe I haven't really explained this particularly well. This Colab notebook is actually just a wrapper around this repository. And all this notebook does is make sure that all of this stuff works on Colab. So really what happens here is automatic 1111 builds all the functionality that you might get through Stable Diffusion. And all the person that writes this, I shouldn't say all, because there's quite a lot of work involved in that. What this person does is every day that there's an update to automatic 1111, the last Ben, this developer, goes in and makes sure that his notebook is then updated to work with Colab. So that's kind of like a complicated way to say that, like, what you really want in most cases is to use the automatic 1111, unless you're purposely using Colab. So we could go in and actually grab all the code to install from here. Again, this is where you run into that issue where, because Vast runs on a root user, Stable Diffusion doesn't really want you running on your root user for various reasons. So you run into issues where this doesn't actually run. But you could go in, and I believe there's installation details here. So we go to the wiki and we go to install and run on NVIDIA GPUs. You will see, in fact, that there is this line of code. Now you could cut this line of code in here and paste it in here. And when you run this, you will get an error message. See, so this script must not be launched as root, and then it aborts. So again, the way to get around this is writing a whole lot of other code to provision a new user that has sudo access, but not root access. It just gets really complicated. So in general, I would say do not use this for Stable Diffusion. But if you want to use other things or want to set up other machine learning boxes, this is actually a pretty good option. And you can really go in and dial in exactly what you want. So I'm just going to stop this and delete it so I don't burn any more money on this. The other thing to know is if you want to, is it under create? Yeah, it's under create. The other thing to know is there's a couple other sliders here that you might want to be concerned about. So one is, how long do you plan on using this for? If you have a week-long installation that you want to run it for continuously, you need to make sure you can rent a GPU that's actually going to be available for the next 7 days. Because not every one of these renters is going to rent them out for that long, right? Again, it's like Airbnb. Like, I'm only gone for the weekend, so I can only rent 2.5 days. Or I'm actually gone for the next month and I can rent it for that long. So max instance duration is what you want to use there. So let's say we want it for 7 days or 9 days. You'll see some of these begin to disappear the longer you look for. The other thing to be aware of is all of these hosts kind of have reliability requirements, meaning how often are they available, or like how likely are they to go down. If you want a cheap GPU, you can turn this down and you will find some cheap GPUs, but they might shut off once or twice every day. And that is going to screw up stuff like a training program. On the flip side, you might say, well, like, I want something that is perfectly reliable and never going to fall apart. And if you ask for something over 99, it's going to say you can't do that. And that's because every cloud provider has some level of SLA where they are not 100%, where they are not admitting to 100% uptime. So all of these have a likelihood of eventually going down, but the higher you keep this reliability score, the more likely you are to get someone who's like, you're never going to shut down on you. But usually that comes with a cost, right? So the higher you make this, the more likely they are to be somewhat of a costlier option. But if you're working for a client, they're like, this thing must not go down. Well, first up, I'd probably recommend like GCP or AWS and having the client pay for it. But if for whatever reason you're doing it on the cheap, make sure that you set the host reliability score to be something pretty high. So all these options, again, this is so configurable that it gets kind of crazy. Like, you can set, however many GPUs you want, bandwidth, space, all these other things, which makes them really cool and configurable, but also leads to kind of like you can spend an hour just trying to pick out a GPU. The other thing I'll mention is you do probably want some decent amount of disk space. Remember, these models are like 10 or 15 gigabytes each, usually. Some of them are like 3 or 4, but they're pretty big. And if you're going to be generating a lot of files, you want to make sure you've got a big disk space. And the other thing to know is that as you crank this up, the pricing usually changes as well. So just beware of that. So that's Vast. Again, I think it's good for some things, but it turns out not good for Stable Diffusion. And I found that out the hard way this week. But it is still a pretty good, reliable result. It turns out what everyone uses for Stable Diffusion is a site called RunPod. And this works very similarly, where it is a cloud GPU. And you can go ahead and sign up. You will have to give them a credit card. I don't think they give you any free credits. You just have to give them a card. Come on. There we go. Excuse me, sorry. So RunPod works on a similar idea. So turns out this particular service has what they call secure cloud, which I think means they run it off a GCP or something else. But they also have a system called Community Cloud, and this is where you can get the cheaper GPUs. So if you click on Community Cloud, you'll see kind of similarly, but somewhat in a different way as well. You have a list of GPUs. What I kind of like about this site is that it's less, you have to go and pick out the exact GPU, and more around, you can just pick out a model, and they tell you whether it's available or not. So you could get an A100, which has 80 gigabytes of VRAM. That's overkill for pretty much anyone, but you could get them. And you'll see that you have to rent them on demand for $2.04 an hour. Pretty expensive. Obviously, we don't need that for our services or for our purposes. Like, again, if I were training, I might want an A6000, which has 48 gigabytes of VRAM. But since I'm not doing training and I just want to use one of these models available to me, I could go in and just look for something that's maybe 16. 16 VRAM would be pretty good, as would any of these other ones. And you'll see some of them are unavailable. So that means you might check back tomorrow and one of these might actually be available. But as of today, they are not. And again, that's because people are renting them, using them, et cetera, et cetera. Prices on these I find are slightly higher than Vast, but not by too much. A 3090, I forgot exactly what GCP pricing was. Did they even? I don't even think they offered 3090s. Yeah, they don't, because 3090s are typically consumer grade. So you could rent a 3090 for. I usually do the on-demand pricing. We'll talk about that in a second. At 40 cents an hour, which is not cheap, but it's like decent. You could rent an A5000 for 44 cents an hour. Well, you could do a V100 for 29 cents an hour. A V series, so I haven't really explained this, but V series is a little bit slower than A series. P series is slower than V series, and then you've got the T4 series, which is the slowest. I don't even think they offer T4s here. Do not. The important thing to look at is GPU VRAM. Stable Diffusion claims it can run as low as 8 gigabytes of VRAM. I wouldn't want to test that, especially if I were trying to make bigger images. I would probably stick around in the 16 size. So I'm going to go ahead and rent a V100. You could rent multiple of them. Again, that doesn't really work for inference. If you're just sharing images, you don't need more than one GPU. If you're training, you might want more than one GPU because it'll go faster. But I wouldn't necessarily recommend getting more than one in this case. So from here, you can also go ahead and hit select. Kind of similar to the other, to Vast, you do need to set your container and volume size. I set these both to 50, which does bring up the price a little bit more. I'm still a little unsure exactly about the difference between container and volume. Volumes are ideal for storing output and other data you want to persist between pod runs. So container is stuff that every time you restart the model, you kind of like lose it. Volume is, say you've got files you want to keep on there, like say model files or other things. So you do have these two different options. I think 50/50 is plenty. That gives me enough space to do pretty much whatever I want. Again, that does increase the price a little bit, but just be aware that it's kind of worth it just to be safe, is what I would say. There are also charges per month So if you were to, this gets confusing. Just like with Colab, you can run a notebook or run a Colab instance, but then you can shut it off and your drive stuff is still there. This kind of runs on the same idea, which is that there is a cost per hour to run the GPU. If you are not running the GPU, there is a cost per month to just store the data on there. Usually what that means, or what I would recommend for most people, is that as soon as you are finished with your run, download your files, we'll look at that in just a minute, and then just delete the whole pod. Deleting the whole pod means they won't be charging you anything extra. The nice thing about this is, let's say you want to shut it off for a day, maybe present to the client some of the work you're doing, get the client's approval, and come back and rerun it. That would be sort of a nice way to use this system, because then you're not losing all your work. You're kind of keeping your work on the pod, and then you can start and stop the machine as needed. That's probably the best way to think about that. Again, probably a rare use case for most people, but if you wanted to, you could do it that way. But in general, I would always recommend downloading all your work when you're finished, using that run, because if you're not, there's a slight chance you could lose those files. I think RunPod will try to keep them, or like do the best they can, but there's probably weird instances of where you could lose your work if you're not careful. Let's go ahead and do that. The cool thing, and the reason everyone likes RunPod for Stable Diffusion, is if you click select a template, you'll see here that there is Auto 1111 v1.5, Auto 1111 v.2, 2.1, and there's some other ones as well. So you could run Disco Diffusion on here. You could run Invoke AI, which is sort of a new one that people are kind of having fun playing with, and a bunch of other stuff. So most people just like this because, like, unlike Vast, we would need to go in and figure out all the installs you need to do. In this case, you could just set one of these up and just run it. So we're going to set up today, we're going to use 2.1. And now that we've got all of our settings set up here, we can just hit continue. Now we need to go ahead and pick our price here. So spot means it's interruptible. That basically means that as long as there are spot instances available, it will let you run. But as soon as someone comes along and says, hey, I want to pay RunPod 30 cents an hour instead of 12 cents an hour, RunPod's going to be like, hey, guy, if you're on a spot instance, you're getting kicked out. Meaning these could stop at any time. Now, again, I do think they will save your work to their volume disks, but you might have to wait a week, a couple days, who knows how long, to get back to your spot instance. Or you might have to cough up more money to get an on-demand price. So I generally recommend, if cost isn't really that much of an issue for you, to just use the on-demand price. Again, it's a little bit more expensive, but it generally means you're going to not get kicked off and not run into any issues going forward. So I'm just going to grab the deploy on-demand price. And now it says, here you go, you're running. And like Vast has a thing called instances, this is a thing called pods. So go over here, your pod. And you'll go ahead and open this, and you'll just see it's basically starting up. So it's setting up a Docker container. It's running it all through the Docker container. And it takes a couple of minutes to get set up. But the nice thing is it installs almost everything we're going to need for Stable Diffusion behind the scenes for us. And the way to connect to this is you're going to hit connect, and then you're going to hit connect via HTTP. If you get an error that looks like this, that just means it's still loading up in the background. So this gives you a URL, but it just seems to, it looks like a 404s, but it's actually because we're still setting up all the code we need to actually run this. So you know how in our Colab notebook, it takes like 10 minutes to get one of those Colabs running. It's kind of similar here. It does take a couple minutes for this to run. So let's see, we'll hit again, and now it's working. And lo and behold, here is our beautiful, the web GUI we're all familiar with, right? You will see here that because we're using 2.1, we actually have by default the 768 model. So this will generate a 768 by 768 image by default. So it is kind of a cool thing. They made a new version that is a higher resolution basically. So we go ahead in here and let's just say a dark, beautiful forest, matte painting. highly detailed, green, flush. And let's say yellow, brown, ugly, dead, city. Go ahead and generate. And that's pretty quick. And this is native 768 by 768. You'll have to believe me. I could open this in Photoshop and look at it, but it is 768 by 768. So that's cool. One of the other things you might be interested in is, so this is a case of where Adam reached out to me this week, yesterday, I think, and said, hey, have you seen the new depth to image model? Can we run that on Colab? And I looked at trying to set it up in Colab, and it turned out it didn't seem to be working for me. So the nice thing is, again, as I mentioned, that Colab notebook lags behind a couple days behind Automatic 11.11, because Automatic 11.11 builds out their features, ships stuff, and the person that makes our Colab notebook has to go in and make sure it works for Colab. So literally this weekend, Automatic 11.11 added the depth to image model. So it works on there, but it does not yet, as of today at like 3 p.m., does not work on our Colab notebook. So this is a great example where maybe there's even a latest and greatest thing and I just want to use it. That's a case where you could show up on RunPod and get it to run. So that's what we're going to look at. I'm going to show you how to get that set up on here. It does actually take a couple other steps that isn't really done via RunPod, or is done via RunPod, but have to use the terminal. So I'll just quickly show you how to do that just so you can use it. Actually, it's pretty cool. So Adam reached out to me and just said, hey, have you seen it? And I had seen it, but I didn't know it was in Automatic 11.11 yet. I found it because I went to the Stable Diffusion Web UI wiki. So this is the tool that we're using. So again, remember that Colab notebook is just a wrapper around this tool. I went to features and I scrolled down to depth guided model. And it said more info, PR, and then it said, here's the steps you need to do in order to run this. So I'm going to walk you through the steps in order to do this. So the first thing is we have to download the 512 depth EMA CKPT. Well, how do you do that? So you click on this, you get taken to Hugging Face, and there's a little link right here to download the actual file. This took me like 10 minutes just to find this little link. So we're going to copy this path. And if you paste this in, you'll see it's just a link to Hugging Face. If you have not yet, I'm just going to drop this in our chat. So I'm going to drop this page in our chat. Make sure that you have access to it and you can see all of the data here. There's a chance if you have not accepted the terms and conditions to this, that you may actually need to accept the terms and conditions before you can download that. So if you go to that link, your page should look like this. And obviously, you might not be running on RunPod and you just want to watch. I'm just going to let you know that if you watch this recording later and you do try to use RunPod, make sure that you check this page and you see exactly what I see here. Okay, so now I have the link to that, that CKPT file. What I need to do is I need to go back to RunPod. And if I open up here, the connect options, there's an option here to say start web terminal. So I'm going to click on that and I'm going to hit connect to web terminal. And I think we played a little bit with the terminal in this class. I know it can scare people. Don't worry. I'm going to give you all the commands we need to put in one by one, so you can follow along with this at a later date to get it. This would probably also be very similar to what we want to do for the Colab notebook. So when the Colab notebook does accept this, I'll probably record a little tutorial on how to set that up for that particular piece. So we need to download this this checkpoint. So if we type ls, that's going to give us all of the folders that we're in. So we're in this folder right now. We're in /workspace/Stable Diffusion Web UI. And if you remember when we did stuff in Drive, we had to go into a folder called SD and another folder called Stable Diffusion Web UI. This folder pretty much matches that exact folder in Drive. So in here is a folder called Models, and then inside of that folder is a model called folder called Stable-Diffusion. So first off, we're going to move into that folder. So CD Models, Stable Diffusion. And if I ls in here, here is our 768 checkpoint. and another file that's a config file. So don't worry about this one, but we'll make that in a second. So what I want to do is I want to install my CKPT file using the path I have right here. And the way to do that, and if this is confusing, don't worry, I'm going to send instructions out after class about all the steps we went through to get this to run. So we're going to do wget, wget, and then we're going to paste in that path. And that is not the right file path. I want this copy link address. So make sure it's the path to the .ckpt file. When I hit return, it's going to start downloading. wget is a command that allows you to take a URL and just grabs the file on that URL. So this is going to download and install. This is a 5 GB file. So you do not want to download this locally and then try to upload it, because downloading big files like that on our crappy consumer internet is really slow. It would probably take 20 minutes to download the file, and it would probably take an hour to upload the file. In this case, because we're going fast internet Hugging Face server to fast RunPod server, this will take about 3 minutes to download a 5 GB file. So while this runs, we're going to go ahead and look at what the next step is. So go back over to Automatic 1111. So it says place this in the model stable diffusion folder. So we're already doing that. Remember, we CD'd, we moved into that folder, and then we're going to download that file. Next, we need to grab the config file and place it in the same folder as the checkpoint. Let's click on this. Let's see what it is. So this is a raw.github user content file, and it is a v2 midas.-inference.yaml. So again, YAML files are like config files, they're like JSON files. All that means is it includes all of the notes we need about this model in order for the web UI to use it and to do the right settings. So we can actually wget this file as well. But you'll notice here that it said rename the config to 512 depth EMA YAML. So we'll need to go back and do that, or we'll need to figure out how to do that as well. So for that, we'll go back over to our environment here, and we'll wait for this to finish. It's only 25 seconds left. Come on. There we go. Okay, so this downloaded. If I type ls, I'll now see that in this folder alongside the 768 model is a 512 model called depth. So next I need to download that YAML file. So we're going to do the same thing. We're going to do wget. We're going to paste in that path. But this time we want to change the name of this path. We want to change the name of this file. So for that, we're going to do -O, and then we're going to type in the model name, which I copied. Let's copy it from here. So it needs to be named this. So we'll run this. This should take a second because it's a very small file. And then when I type ls again, you will see I now have a 512 checkpoint and a 512 YAML file. So at this point, usually what you then have to do is restart your pod. And we will definitely do that in a second. But one thing that I found is that the Docker image that is running on RunPod is not up to date. So we actually need to update this folder with the latest code in order to make sure we're running the latest version of this to support this particular model. So the way we're going to do that is we're going to do cd .. // So that is going to move us back to the Stable Diffusion Web UI folder. Let me make this a little bit bigger for everybody too. So now we're in this Stable Diffusion folder, which is a GitHub folder. So from here, we can just type in git pull. And this just updates all of our, all the code in that code base. And it turns out because the change for that depth model got released this weekend, RunPod is not yet using the newest version. So we just had to update this. So now that we've updated this, now we can finally go back to our pod and we can hit this little hamburger menu here and we can do restart pod. This is just like when we uploaded a new model to the Colab notebook, we had to restart the Colab notebook. Or when we would add an extension to the Colab notebook, we had to restart the Colab notebook in order for it to work. Same concept here. Every time we add a new model, we need to make sure that we restart the notebook so it can find that model. And this again will take a minute or two as it just spins up. And you'll even see if you go back to your terminal that it says connection closed, and that's because we restarted that notebook. Likewise, this URL will no longer work for Stable Diffusion because every time we restart our notebook, we get a new URL. And at this point, I should now be able to get access to it. So let's go ahead and see if that worked. Let's go ahead and connect via HTTP. And it's loading. And if I click over here, I now see 512 depth EMA.ckpt. So I'm going to select that. It's going to take a minute or two to load this. Now let me explain what this depth model does. So if I click on more info here on the GitHub page, you'll see this is called depth conditional stable diffusion. And if you look at this image here, so imagine that I have an image of a person and I want to use image to image, and I actually want the next image to be in a similar position. As we've seen with image to image, if you set the denoising strength really high, it alters the image quite a lot. And so if you can imagine for something like portraiture, if you want to just change little details of someone's face, but keep the overall shape structure, image to image as it worked previously or as we looked at before, wouldn't really work because it would change a lot of the facial structure. So the Stability AI people create this new model that is called depth image guidance. And what that does is it actually takes the image and it converts it to what we call a depth mask or a depth image. You'll probably have seen, if you work in 3D, you've probably seen a lot of these because, excuse me, what this image says is stuff that is the lightest is closest to you, and stuff that is in the darkest is further away, is the furthest away. So what we do is we have the model create this mask, and then we still provide it a text prompt. And then what it can do is it takes the text prompt and the mask, and it tries to guide the image toward that output as closely as possible. So what's really cool about this is we can actually have a much higher denoising strength, make a lot of big changes to the image, but have the essential structure of the image itself not change. That's where this is really powerful. This keeps a lot of the structural data while also sort of replacing pixels. So it's a really powerful tool and it's pretty cool. So let's see if this is loaded. It has not yet. If you get that error message, I think you just need to sort of refresh the page. And then we'll go over here. Error, come on. All right, there we go. That fixed it. I don't know why I'm getting errors there. Something weird is going on. So again, remember, this is an image-to-image model. So you do need to use the image-to-image tab. Let's go over here. Let's grab a portrait. Let's just click on images. Of course, there's always butts. There's always butts in these images. Sorry, I should remember that from my last time recording this. So let's just grab a portrait that looks pretty good. I used this one earlier today, and this one worked pretty well. So I'm just going to say open image in your tab, save image. And I do recommend that you go in, because we're going to use a square image, let's pre-crop this to square in Photoshop or in Preview. And we're going to use this. Okay, so now we'll go back to Stable Diffusion and we will drag our image into our image-to-image section here. So this works just like image-to-image, except we have to make sure we're on the depth 512 model. So let's go ahead and let's change this image. So let's go ahead and make this image of an old man instead of a woman. So let's say a portrait of an old man. And let's spell things correctly. Old man, I keep getting errors here. Let's just see what's happening here. Let's try this. We'll see what happens. I think I might need to rerun this or restart this pod. Let's see. Portrait of an old man. Let's say Tri-X film. So let's make it black and white. Realistic photo. And let's say vintage. And then for these, let's say negative, we want a woman. We want color. We want, I don't know, modern. Let's just leave it at that. All right, I'm just gonna run this and see if this works. Yeah, why do I get an error message here? I ran all the steps. Okay, let me see if there's anything in my logs here. Attribute error. Let's do this. Let's go back to our web terminal. And let's do git pull again. Already up to date. ls. .512.512. Let me just double check and make sure that nothing has changed in the past couple hours on auto 1111. Last note was 2 days ago. Okay, so this should work. Let me just restart the pod and see if there's some issue there. So actually, let's stop the pod. And let's restart pod. Yeah, so Sean, that's a good question. I actually saw someone asking that. I'm not sure the training technique required to train on top of these depth models. Technically, it probably should work. I just don't know what the process would be. I don't know if it's you need just depth images or if you need both depth and text captions with it as well. So Stable just put this out like a couple weeks ago, and I don't really think this is the first time I've seen them get pulled into like open source tools. And I saw someone actually asking in one of these repos whether this was even possible. So I mean, let's sort of see. I'm not entirely sure, to be honest. Okay, I just want to make sure. Okay, that's all still there. Okay, so that's a good sign. Let's see if this opens. Here we go. So I'm just going to see if this loads correctly now. This, of course, worked fine earlier today. So if it doesn't work today, that'll just be my good luck, I think. Oh, it errored out again. This was working for me earlier in the day. The only difference is I was using a different GPU. I would hate to find out that it's the GPU that caused this issue. That would seem ridiculous, but it could be possible. See, now nothing is working. That's always a good sign. This file is most likely corrupted. The only other thing I can think is that maybe that checkpoint file is corrupted. Let me do this. Let me drive. It's a 0, so that's not going to work either. Okay. Let me try re-downloading that file and see if that fixes it. Sorry, y'all. This is one of those things where it was working totally fine earlier. All right, I'm going to try to re-download this and see if this fixes anything. Holy crap, this is way faster. What just happened here? All right, so we need to remove this one. And we're going to rename this one to that. Okay, let's see if this works. We'll give this one more shot. If not, I will we'll take a break and I'll show you what the files look like on my other machine. All right, while we wait here, let me just let's check to see if the last Ben has mentioned any updates here. So his last commit was 12 hours ago, so I don't think he's added the stable diffusion or the depth model yet. Connect. Come on. All right, feeling better about this since it hasn't thrown an error message yet. Let's go to our logs. All right, so far so good. That's not a good sign. Yeah. The only thing I can think about is that maybe this is because of the V100. I was using an A series either today. I don't think the file names are off. It's a good question. Let's double check. 512 depth ema.ckpt. Let me double check to make sure that's right. .512 depth ema.ckpt. That's correct. And then rename the config to 512 depth ema YAML. 512 depth ema YAML. That's correct too. All right, here's what we're gonna do. Let's take a 10-minute break. I will try to reload this in an A series GPU to see if that is the issue. If it is, then we'll come back and play with it and look at things. If it isn't, then I will show you some examples of what I've been able to make when I did get it to run. And then I've got a little bit of stuff to wrap up before the end of class as well. So let's just do 10 minutes. And hopefully when we come back at 40 after, I'll have this figured out. All right, see you in a couple minutes. Whew. Okay, it actually worked. I have no idea why it worked. So what I did is I reset it in an A series GPU. So this is an A5000. I'm not entirely sure if it's the GPU that's the problem. I was also I looked on the Auto 1111 issues. Seems like that error message is pretty common. And they were just said just re-download the model. And I was like, okay, well, I already did once before. But when I switched over to an A5000, it did work. So here you'll see I put in old man as my text prompt, and I said, don't do young woman, as being as lazy as possible. And you'll see I got an old man that has a lot of very similar characteristics. Pretty good, actually. The key here is everyone has sort of said the issue with these models is that they suck at hands, right? Well, look at this. If I use a depth model to guide the hands look pretty good. I got some wrinkly older man hands here, but they look pretty legible. Well, actually, if you look close enough, this is her middle finger, and this is his index finger. So it still isn't perfect, but those look more hand-like than most stable diffusion models can generate. So overall, pretty good. Yeah, the neck is pretty gnarly for sure. So the other thing we were trying to do in class earlier today was we were also trying to get short hair out of this person. Let's say old man, short hair, Tri-X film. Spell Tri-X correctly. Tri-X film, photo, realistic. And let's say ugly, colorful, young woman, long hair. This is also what happened in the previous image. What it ends up doing with the depth map, instead of getting it hair, it becomes like a cowl or a cape, right? It's like a very funny thing that, again, remember that the output or the way it's conditioned is on a map. And this map is probably grayish, whitish. So it has to fill that in. And if you say, hey, don't put hair there, it's going to figure out something else to put in there that could be realistic for a portrait. So this is a pretty powerful model. The neck is still a little gnarly in there, but you could probably in-paint that and clean it up a little bit. So overall, this is a pretty cool tool. And Nat, you asked, will this work for only portraits? It will not. It will work for other items as well. So you're actually playing with this in class before. Let's actually do it. Let's try it. So let's say full body photograph. God, I don't get anything pornographic here. Images. Let's just take one of these images here. Let's try this. Oops. So I'm just going to quickly crop in on this image so we get a square. Okay, interesting. Let's see if that works. Save. So let's say old man, short hair tracks film. Let's just say full body. I think that should work. And we'll leave all this as is. Although this person already has short hair, so hopefully we don't need that, but let's just see. Okay. We apparently get to keep, now it's like a red bathing suit or something. So we'd say, let's say black bathing suit. And let's remove red bathing suit, or let's just say remove red. Okay. Really wants to keep that red suit. Let's say black clothing. Black clothing. Say black and white. Keeping that color in. This is where I would just go into Photoshop and just grayscale the image so I could just fix it that way. But you will see, of course, with full body, the full body figures tend to be a little bit less perfect, right? You can see there's some issues around the feet area, that sort of thing. But overall, this is pretty good. You've got a nice like old man figure. They got some sinewy muscles there. He's wearing that red bodysuit really well. Yeah, so I mean, this is pretty good. Maybe not perfect, but this is good enough where, you know, again, you could kind of imagine almost maybe collaging something in front of the feet so to hide them. But this is a pretty powerful tool. And I think it's really interesting that you can use this as guidance for structure. So I got the idea, I was like, oh, I bet you this works really well for video, right? Because a video, what you really want to keep is that structure. Whereas image to image, when we use do video, we tend to lose a lot of that structure, right? It tends to flicker a lot. So I actually did run this earlier today. Where is it? Downloads. City drone output. So I'll play this. You'll see the structure is really good, but it still flickers a lot. So the structure is pretty stable, but you still get a lot of flicker. And I bet if I went in and play with this a little bit more, like maybe change the denoising strength. One thing to note is that you do still have denoising strength here. If you crank this up, let's actually crank it up here and just see what happens. Maybe that will help with eliminate this sort of pinkish outfit. Whoa. Okay, let's put a little hand there. Maybe I just should say, hey, wear clothing, buddy. But you can, okay, I'll scroll past it. This is a little much to be watching today. CFG scale is also a thing you could change. So you crank this up a little bit more. Man, I really just don't want to see that guy anymore. Let's do this. This is gonna, like, my YouTube video is gonna get flagged. All right, so let's just generate that. Whoa, okay, so that the CFG scale is too high. Anytime you see, excuse me, anytime you see color like this, like a really bright outlandish color, that means your CFG scale is too high. But at least that guy's not naked anymore. The other thing I just noticed here is my size is set to 768 by 768. I should probably do 512 by 512, since this model is meant to be 512 by 512. So let's see. Okay, now he's wearing boxers at least. Okay, so oh, man, didn't know how much nudity I was going to show people today in this class. But so we can also play with denoising strength. We can play with these other values a lot. And what I did, I believe, for my video was I just switched to batch image to image. I did the same technique we looked at last week, 2 weeks ago, 3 weeks ago, however long ago, where we gave it a folder of images and then I set it to a folder output. Also, the sampling steps could probably be a little bit higher too. And I believe I set the denoising strength for this one, for that video, at about 0.7. I would probably, if I were going to try it again, I would probably try to set it like 0.4, 0.5. The downside with using that is if you may have a big change image to image, you don't get as good of solid results out of that next image. So I was going from a building video to the sort of like cyber, like, I don't know, PCB board kind of look. And if you try to set the denoising strength too low, you don't get that really like good circuit board look. So maybe with different prompt or different values that I could get better options. So yeah, this is a pretty powerful tool. And I would love to, I think, the next step will probably be that they actually do generate better video with this tool. I could see a world where like, maybe you're feeding in a depth map and you're feeding in the previous image. And you're almost using those two as how to steer the video. I think that could be pretty interesting or pretty helpful. So yeah, that was the depth map. It took me 20 minutes longer than I wanted it to take just to show it, but this again, you can't run this today on Colab. So using RunPod is a good example of how you might get around that to actually be able to run this and use this tool without having to like buy your own GPU, right? So someone in my previous class had asked like, well, if I just want to run this locally, could I? The challenge with running these locally is you can run it on an M1. There is a way to set this up on your M1 Mac. The challenge is it takes about 10 minutes per image to generate because it's just really slow. Your GPU is on your local computer is not fast enough to really speedily generate these images. So that's one option. Your other option is you could buy a GPU. You need to buy an NVIDIA GPU in most cases, and that then requires you to either use Windows or Linux because you can't set up an NVIDIA GPU with a Mac. Then you are basically building your own computer on a Linux, and then you have to know how Linux works, and you need to set up everything. And the GPUs you kind of need for this, the GPU that we're using here, which is an A5000, I believe if you go on eBay, let's just check today. If you go on eBay to try to buy one of these, I think they're going to be at 4K. Oh, actually, that's better than I expected. Okay, that's not bad at all. I mean, it's pre-owned, but $1,200 would probably get you an A5000. Those have come down quite a lot. Thank God the crypto world is collapsing. All the GPUs are cheap now. So again, $1,000 is still a lot, right? In order to actually make up your money on, this is an hour. So how many hours is this? This is $4.50 an hour. So let's say, what is 11? Say 1,200 divided by what did I say? 45. So you need to run this for 2,600 hours to break even. So most of us are probably never going to break even like that. I will break even like that because I do crazy training with all my models, which is why I own GPUs. But for most of us, we probably don't need to buy one of these. Just not really worth the cost. So with something like RunPod or Colab, like this is plenty good for what we want to do in order to generate these images and videos. So yeah, I think RunPod would be a really great example if anyone wanted to like build their own little GPU tool to have these things. Again, good for exhibitions or good for like, hey, I want to set up a website for like a weekend and have people play with it. Sort of outside the scope of this course would be how to connect a GPU like using terminal with a front end that you can build yourself. That'd probably be involve some like Python where you're actually sort of building a web page and that sort of thing, or JavaScript or something. So a little outside the scope of this class, but if you're interested, there are probably materials on how to do that online. But again, I think this is a fun little tool, and it is much cheaper than running it through GCP or AWS. So again, if you do feel like, man, I just don't use Colab enough to really like warrant the $50 a month, but I do find that one day a month I want to use this tool, I think RunPod's a good example. Again, you can put $50 on it and run it for a couple hours every day, or you can just run it once a month, and it'll still work pretty well. One last thing I do want to show is, let's say I want to get this image. Let's say for some reason I don't know that the save button is here, right? So I can download it directly from here if I wanted to. Can't believe I want to download that guy, but so I do. At least I'm downloading the one with boxers. Let's say I wanted to get access to this file. How do I go about doing that? So if you go to this little README here, or let's say I did this with video, right? Let's say I made a whole big video and there was a big, huge file that I needed to download. What I could do then is, you might think you could go ahead and click Cloud Sync. And you'll see here you've got AWS, Azure Blob, Backblaze, Dropbox, and Google Cloud Storage. We will not see here is Google Drive. So I have a Dropbox account, that'd be fine with me. I somehow, for some reason, pay for both Dropbox and Google Drive, but so it is. If you want to get access to Google Drive, there is a way to do it. And it's kind of buried in this README here. So in this README, it says uploading to Google Drive. If you're done with the pod and would like to send things to Google Drive, you can use this collab. Let's go ahead and open that. Okay, so for this collab, what you'll need to do is you will mount your Google Drive. Let's go ahead and run that. And then you will run this cell. And this will install some stuff. And then the other thing you're going to do is you're going to need to basically ask for access to that file. So the way to do that is let's go over here to our terminal. So again, if you didn't have that open, you would go to Connect, Start Web Terminal, Connect to Web Terminal. And let's see, in here, where do these get saved? These get saved to outputs. So we'll go to CD outputs. And then here we have image to image images. So what you could do is, what I would probably recommend you do is you could zip a folder, except there's a little trick here, which is that this pod, for some reason, does not install all of the zip commands you need. So I'll share this with people as well. In order to get zip commands on here, you need to do apt-get update. And then you need to do apt-get install zip. Cool. So let's say maybe I just had a bunch of images in this image to image folder, right? I just run this for a couple hours and I generate a ton of images and I want to download all of them. What I would probably do is I would just zip this folder up. So we do zip -r, which is recursive. And then we're going to give it a folder name of image to image zips, or image to image images zip. And then we give it our path, we hit return. So this is going to make a zip folder of all of my images, right? So now if I do ls, I'll see in here I have my zip. So now what it says to do in Drive is it says to pass in this command in terminal. So RunPod ctl and then send. So we're going to do RunPod send. Let me move this up a little bit so it's not lost down there. RunPod ctl send, and then we go image to image dash images dot zip. And what this does, it says, hey, here's a little code to get access to that file. So we'll copy that code, come back over here, and we'll paste that in here, and then we'll hit run. And now what it does is it has moved our files into our Drive folder. And if I look in my Drive folder, there it is, image to image images. So I could download this here, or I could go into Drive. If you download it from Drive, it's a little bit faster, but it's 4 megabytes. So I can go ahead and just download this and we'll look at it. So again, RunPod, probably better than Vast because you can actually do this. I will say this process is pretty annoying, right? You have to like remember all the little code commands and stuff, but at least it's possible to move it into Drive. The other way you would have to do this if you didn't have access to this little tool they have is through a setup thing called rclone, which is like a whole, it's like an hour-long tutorial on how to set up that. So thank God for small favors, this thing works. So again, I would probably say if you're gonna do Stable Diffusion, RunPod's the way to go outside of Colab. Again, I'm not seeing anything here that like says like, if I had to wait 2 days to get access to that depth model to run on Colab, that'd be fine with me. Whereas, you know, in this case, all this rigmarole feels like a lot, but again, to each their own. So you are able to get access to this file. We can open it, and I'm hopefully not going to show us our naked person. Yeah, okay, so there's our boxer guy. All of our other images are in here too. I guess the safe for work filter got turned off with this model. I don't know. Anyway, so that is how you use RunPod. And I do think, you know, there's lots of cool little features here that do allow you to do stuff. But it's a little bit more work, and you do have to go in and dig through a lot of documentation. But that's why you're paying for this class, so I could do that for you. So that's how RunPod works. Again, not a lot of use cases where it might make more sense to do this in Colab, but here is one that actually came up today that made sense. So we get to play with this beforehand. Any questions about that? Cool. Oh, last thing you need to do is you want to stop your model. And if you are done, like I just download all my images, you want to make sure you trash your model. Trashing your model means they cannot no longer charge you for anything, right? You're done. Because if you leave this as is, I don't know if it says it here anywhere, but they will be charging you. They're charging you a certain amount per month that is prorated because you still have files sitting on their servers. As soon as you hit delete, you are saying, I do not want anything from this pod. You can delete all of it and you can stop charging me. Cool. All right, so that was pretty much everything I wanted to show you today. One thing I did want to talk really quickly about is a question that came up in my previous class, which is like, this class was great, loved everything. I swear they did say that. I'm not just making that up. But they said, but there's so much stuff changing. Like literally every week we come into class and something's new. How do I stay up to date with all that? And I said, that's a great question because it's hard for me to stay up to date on this. But here are a couple of things I would recommend for people. So obviously, especially in the Stable Diffusion world, things are changing so quickly. And it seems like every week a new thing is coming out. What I would probably do is the first thing that I would do is Discord. I know not everyone in here is a Discord person. I am not a Discord person either. But this is how you can tell I haven't used Discord on this computer in a while because there's like 5 new updates. If you go to this one, so let me invite you all to this Discord. This is the Stability AI Discord. These are the people that make Stable Diffusion. In here, you can go to announcements. And in here, there will be a bunch of announcements about all the contests they run, but also you'll see Diffusers v2.1 has arrived. How does this all work? You'll also see that there is Stable Diffusion v2.1 preview on Dreambot. So there are a bunch of announcements in here about features they release. Now, what does that mean? That means they're going to tell you about 2.1 being released or 2.2 being released, or about any other new big changes that come from stability. That will not mean automatic 11.11 updates. That will not mean other community updates. That'll just be stability updates. But if you were looking to find like what are the new things they released with 2.0, it's probably buried in here now, but they did announce 2.0 on here and they said, here are all the updates we're going to include. So here you go. So what's new? Updated in painting diffusion, an upscaler, and depth of image. So this is where they told you about all of the latest updates to their models. Now, doesn't really say how you go and get those. There might be a blog post, there might be other things. What I would recommend from here is, let's say you saw depth of image. What I would probably do, quite honestly, is I would go to YouTube and I would go Stable Diffusion, depth of image. And here you go. Here's a tutorial from 13 days ago on how to install depth model in Stable Diffusion 2.0. And then here's a bunch of tutorials on how to actually use them. Now, not every one of these is about that exact model we just looked at. Some of these are about some crazy extensions that existed before. Some of them came out a couple weeks ago, that sort of thing. So what I generally recommend, or the way I approach these things, is I watch 3 of these videos and I figure out who actually knows what they're talking about. And I figure out, like, are they all saying the same thing or are they all saying different stuff? And you kind of have to read between the lines and kind of just like blur your eyes and try to figure that out. More often than not, I find in many cases, people are all saying the same thing and they're all either following each other's tutorials or they are actually aware of what's going on. Then you have to go and try it yourself. And I will admit that is a lot of process. That's basically what I do every weekend before we meet on Mondays. Not all weekend, it's like a couple hours here and there. But it is a challenge, I will admit. But I do think YouTube has become, like, there are so many tutorials on here. And you'll find a couple of these people are like generally pretty good. Who are the people I generally like? Nerdy Rodent is generally pretty good. Although this is not necessarily about that depth of image model. There's another person on here who I usually like as well. Yeah, this person, Sebastian Kam. He has the worst jokes in the world, but other than that, his tutorials are good. He is very much into like bad puns and stuff. So I generally I like those two folks. Some of these other people are also good. I will say sometimes I've been bitten by some of these people. I found this person generally has good tutorials, but is sometimes wrong about certain key features or about how to set things. And that I would learn from reading the wiki. So that's the other thing you could do is you could go to that wiki that I was showing everyone, which is wiki, this one. I have to say that for an open source project, this is the best documented web page I have ever seen. They document a lot of all their updates, a lot of their new features, other things in here. So again, remember that our Colab notebook is just a wrapper around this, meaning that sometimes stuff that's listed here is not actually available in that Colab notebook, but 9 times out of 10, 95 times out of 100, it actually is. So we didn't even cover everything that's in this features section, but I highly, highly recommend that if you're really interested in digging into this, you should read through every one of these features and try them out. For stuff like the in-painting model, is that up here? Yes, so for in here, stuff like in-painting, or for here, like out-painting. So if you remember, I told us a couple weeks ago that the out-painting doesn't work particularly well. That was one of those things that I kind of got the wrong impression from a YouTube tutorial that said that. They showed examples, and I thought the examples looked pretty bad, so I was like, oh, they must be right. Then I went here and I read this line. Out-painting, unlike normal image generation, seems to profit very much from a large step count and a high denoising or a high CFG scale, and a step count of 50 to 100 with Euler ancestor or DP2M ancestral samplers. So what it turned out is the person whose tutorial I was watching was not setting this very high. They were setting this to like a step of 20. And what it says here is set it to 51 to 100. So I might have given this class bad information because I got bad information for that tutorial. I would probably go back. I still don't think these are particularly good. DALL-E 2 is probably still better than this, but you can see that it's better than the result that I saw through that tutorial. So again, I recommend reading through this because they also do document sort of like what are the best steps to take with these things, and how do you actually go ahead and like use these features. So I would definitely recommend reading through this wiki just to make sure. And they keep this pretty well updated. Again, they added the depth model pretty quickly after they added it. And as always, the other thing you can look at are issues, which are pretty gnarly because there's a lot of issues in this repo, but there are a lot. So it is a challenging place to stay up to date on. This is where I would say find a couple YouTube people you like, who you find the way they explain stuff matches up to how you want to learn, or like they're just showing cool stuff. A lot of these people, like YouTube has become like people try to release videos like the second a thing's released. So there are pretty up-to-date stuff here. You can also filter this by last update this week. And you can sort of see how this works. I'll be surprised if this person actually has, yeah, this person has probably already gone ahead and done all the steps needed. So that's probably what I would recommend doing here. There's lots of different videos and that sort of thing and tutorials up here. I'll probably try to keep up. I will not be on the same level as these people where I'm updating every hour. But I tend to release videos, or like when I'm not teaching class, I tend to release a video every week or so, just to try to keep up with new stuff. So what I will probably do over the next couple of weeks is actually go through that wiki and like do little tutorials on every one of those steps. So just keep an eye out for that. Let's see. There's also a lot of people on Twitter who do text to image stuff. In general, following Emad, who is the CEO of EMOS stock. This is the CEO of Stability. I think he's kind of a tech bro and is kind of frustrating to follow, but he does release a bunch of announcements around his own stuff. So you can find that. For general machine learning stuff, this is my favorite person in the world, AK Halik, I think is how you pronounce that last name. This person just goes, so they work at Gradio, aka Hugging Face, and they just constantly retweet when they find really cool papers. So they will often find cool papers on various topics of machine learning, and often they usually, because they work at Hugging Face, they will also link to if those papers have code or something on Hugging Face. So lots of really cool options to find stuff. Now, they will throw a ton of things at you. I have a bookmarks. I think I would guess 50% of my bookmarks on Twitter are from them. Maybe not this week. But yeah, there's just a bunch of really good tweets that they have about cool models to check out. So there's a lot there as well. So that's probably where I would start. Otherwise, you can follow me on Twitter or social media or ask me questions. So yes, so also I should say, even though this is the last week of class, I will be posting a poll for us to set up some time to do a show and tell. So it'll probably be this same day, the same time, and we'll just pick a week in January to meet. I know that many of you have found that to be really helpful. Like once we go through all the material, you want to sit down for a couple weeks and actually make a little project, then come back and do a show and tell. I highly recommend that. It is a great way to learn. And because of that, I will also be around if you need help between those weeks. So if you want to do an office hours or anything with me, I probably won't do like a weekly one. I'll just say, hey, if you want to set up time with me, DM me over Slack or email me and just tell me what times you're available, and I'll find times to make myself available with you. But yeah, so for the next couple weeks, like it's going to be kind of free form. Just reach out to me when it's up time to chat. Obviously, holidays are approaching. My schedule between the holidays will be a little weird. So I'd say this week, first half of next week, and then in January would be great times to reach out and chat. Okay, that's pretty much everyone I want to talk about. Are there any questions or anything that I didn't cover yet that people want answers to? Yeah, that's so the Invoke AI. I actually have not played with Invoke AI yet. I have been so busy just dealing with this class that I have not really played with it. I did see this video, and I meant to look at this week from this person, Sebastian, who says, you know, of course, in this like YouTubey way, is this the auto 1111 killer? Maybe not. I don't know. So yeah, it looks like latest stable diffusion UI with great user experience. So I would assume it's probably just a different experience. If I had to guess, I would imagine that they are not as up to date on all the new latest things as auto 1111 is. But I could be wrong. So maybe I'll take a look at that this week and let people know if there's anything interesting here. I love a slick web GUI. Nothing sells me on this like a slick web GUI. So yeah. Yeah, any other questions? Oh, okay. So another question about upcoming classes. So I'll probably announce this either in the next week or two, or maybe in January. We'll sort of see what I get up to. Probably in February, I'm going to start a class that is just going to be about, I'm currently describing it as neo-data assemblage video. So basically what I mean by that is, if you've seen my Scream Scenes project, where I take a bunch of video clips and we resort them by various materials and other things, it'll be basically a class on all the techniques to do that. So what I think we'll be doing is we'll sort of like, as a group, we'll kind of all make a data set of video clips, and then we'll use various tools to sort of like understand what's in the video clips. So maybe we'll use something like Clip to actually describe what's in the image. Maybe you'll look at some color tools, some other tools, and basically what we'll create is this really interesting little way to collage video together, right? So we could maybe take all the clip embeddings. So maybe Clip says, you know, a monkey riding a dolphin, and I don't know, a dog riding a monkey. And then we could say like, hey, play these in these sequences, right? So we'll probably be doing stuff like that. So pretty much anything you see on my Scream Scenes page is going to be stuff we're going to be doing. So we'll look at how to use open pose to figure out crop, like how deep the camera is, how close the camera is. I have plans to look through, there's some other tools around how to actually figure out like what focal lengths are being used, like those sort of things. So there's lots of really cool stuff. So it'll all be around video, but it'll probably use a mix of non-machine learning, but algorithmic tools, and the machine learning tools that are algorithmic, and then a bunch of other creative ideas as well. So I'm kind of still trying to formulate what the class structure will be. I don't know if anyone in here took Sean, I know you took the experimental film class, right, with me. So I think we'll probably do something like that, which is like, what we do is we'll watch, basically during the week, I'll assign a couple of videos to watch, usually like less than an hour in total, of probably like experimental films that all use found footage throughout the past, I don't know, century of filmmaking. So we'll watch some of those, and then what we'll do is we'll take ideas from those and apply them to our next grouping of material. So that's kind of how I'm planning on structuring it, because there's a lot of really cool experimental films that use found footage and use other found materials. And I think we can sort of talk about them and contextualize them as using these tools as sort of the modern version of that. So yeah, so what I'll do is I'll announce that in our class channel. Usually I try to give people that are in my classes first dibs at those classes. So basically that and my Patreon, people will get that link before anyone else does. So you can sign up ahead of time if you want to. Yeah, so that's probably what's coming up next. I don't know. I'm actually not teaching an ITP next semester, which is awesome. That gives me more time to do other things. So I don't know if we'll be doing any other machine learning stuff. It just kind of depends on like what else happens in the world in terms of, you know, what other machine learning stuff comes out. I feel like we literally are looking at like the latest versions of Stable Diffusion in class here. So fingers crossed, I don't need to spend any other time like doing more demo videos, but I probably will of that stuff. But yeah, I want to focus on the video stuff. I like to do some stuff that's a little bit more just like experimental and more just conceptual work, and then do some of the classes like this that are really about like, okay, here's what's new in machine learning. Let's go through all the tools together, that sort of thing. So it's usually like I don't know if it's a one for me, one for everyone else, but it's like a one for like more experimental, cool ideas, and then one that's really tutorial focused. Cool. Any other questions? Anything else I can help with for this material? If not, that's fine. We can wrap up a little early. So again, I know we kind of ran long here, so we don't have time for any demos, but I'd say if you made anything cool this week that you want to share, please share it in our Slack channel. And what I will do is then also probably the next day or two, I'll put up a poll just for us to try to figure out what Monday makes the most sense in January for people. Sound good? Cool. All right, thank you everybody for a really fun class. I hope you learned a lot. I hope you found lots of things helpful. And even if I don't see you in the next class, I hope to see you around the internet. Please always reach out to me if you have any questions. Cool. All right, thanks so much, everybody.
Thank you.
Bye.
Bye-bye.
Yeah, bye, everybody.